Equations Day 2. Today what we're going to look at is we're going to look at three variable systems. Now notice that with two variable systems you have two equations. Three variable systems you have three equations. This isn't a big deal when problems are given to you, but when you're reading word problems and you notice there are two variables in the word problem, you only have to make a two equation system. If you notice there are three variables in the problem, then you must make three total equations. Now the best way to do this without the use of a calculator is by either using substitution or two variable linear combination. We'll look at both so that you can see what works best for which scenario that there is. Okay? So in question number 1, you'll notice that a value is given to you. That is x equals 2. Therefore, in the other two equations, I will substitute 2 for x. 2 times 2 minus y plus 3 z equals negative 2. 5 times 2 plus y minus z equals 14. What I will do with this now is I will solve both for the two. I will get like terms on each side the same. So I'll put this in standard form is what I will do. ax plus by equals c. And then from there I will use linear combination to eliminate one of the variables and solve for the other. So that means once you move your value over, you get negative y plus 3z equals negative 6. In the second equation, once you move your value 10 over, you get y plus z equals 4. Once you've done this, now you have a two variable, two equation system. You can use linear combination to solve. Recall that you're looking for the variable that has the sign change and the coefficient that's the same. In this particular problem, that is very obvious. The y cancels out. That becomes 4z equals negative 2. Oh, I really wish I would copy these down properly. I really apologize for that. Subtraction, not addition. And that becomes 3z minus 1, which is 2z. 2 divided by 2 is negative 1. So your first answer is z equals negative 1. Now what I can do is I can go back to either one of these two problems that I eliminated or simplified the x from, and I can substitute z to solve for y. I'll take the second one because it's a much smaller set of numbers, and that's going to be y minus negative 1 equals 4. So y equals 3 is the answer. In the final process, all I need to do here is simply say that x equals 2 because it was given. Alright, now from here we've done linear combination. Here we will use substitution. If you'll notice, in each of these a different variable is used. A different variable is missing. Okay? So we will solve each one accordingly for that variable. For example, this will be z and this one will be y. And then from there we can use substitution in the original problem to actually find the missing value of x. Alright, so the first thing we get is z equals negative 2x plus 12. The second thing we get is that y equals z minus 3. Now I'm going to take these two values of z and y and I'm going to go to the original or the first system equation, and I will be substituting z and substituting y. So it's x minus 2 minus z, x plus z minus 3 plus negative 2x plus 12 equals 10. This was y and this was z. Now they've been substituted. I am nearly there with the variables. Notice that there is a z still remaining. If I go back here and substitute one additional time, you'll notice that I will get a string of x's and I can solve my equation. X plus negative 2x plus 12 minus 3 plus negative 2x plus 12 equals 10 is the final substitution you'll need to make. With problems like this, you will most likely have to do a second substitution right there. Okay? The total number of x's I have is 3. The total number of numbers I have is 21. And that's a negative 3. Thank you very much. Equals 10. Solving this for x, you get x equals 11 over 3. I'll go back into one of the problems and I will solve for the other variable. The easiest one to work from right now is that one. So I'm going to substitute 11/3 into 2x plus z equals 12. In solving that equation for z, you get z equals 14 over 3. And now I can pick one of the other two remaining. It does not matter which. I'm going to use this one. I'm going to substitute z, and I get 14/3 minus y equals 3. In solving that equation for y, you get y equals 5 over 3. In the final system, you'll notice that all three have 3 variables in them. So we cannot eliminate using the method we used in the first example, nor can we use substitution as we did in the second example. Here's how linear combination works on 3 system variables equations. The first thing you're going to do is list your equations as 1, 2, and 3. The second thing you're going to do is you're going to rewrite equation 1 and equation 2. So that's going to be 5x plus 3y plus 2z equals 2. 2x plus y minus z equals 5. We are going to eliminate one of the variables and we will have a resulting 2 variable system of equations. Okay? So notice here that the z has a switched symbol and we can easily turn the 1 into a 2. So I will multiply and I will multiply by 2. So I get 4x plus 2y minus 2z equals 10. I'm going to use linear combination to combine this into a single equation. 5 plus 4 is 9x. 3 plus 2 is 5y equals 12. I will be doing the exact same thing for the second and the third equations. 2x plus y minus z equals 5. 1/2 x plus 2y plus z equals 8. Linear combination, that's going to be 2.5x plus 3y equals 13. Now that I have eliminated the same variable from the first 2 equations and the second 2 equations, Now the resulting system is a set of two variable equations, which I can eliminate one more time. Okay? So I'm going to choose the y values because they're easier to make the same than the x's are. I'm going to have to pick the 3 here, and I'm going to have to pick the -5 here. Now it doesn't matter which you do, either way will be acceptable. So I get 27x plus 15y equals 36. In the second one, we get negative 12.5 x minus 15y equals negative 65. Cancel, and the resulting equation is 14.5x equals negative 29. X equals negative 2, and then you go back in using substitution methods that we used previously and substitute for y and get 6, and one last time substitute for z and get negative 3. Be prepared tomorrow to have a discussion about the 3 equations and the solution that you came up for this particular system of equations.